So in this video I'm going to look at one of two slvr5 Super VHS decks that were given to me. Of the Sony VHS machines, this was one of the better machines that they made because it's Super VHS. It's got the nice fake wood side panels on it. I'm not even going to plug this thing in until I get it open because I want to check some mechanical parts in it. These had the gears that were prone to breaking. Oh, no screws. That one's got no screw. There's a screw in one side but not the other, so this side panel should just pop open like that. Special screws to hold the side panels on. And then there's a couple more screws to hold the unit together. There were a couple major common problems with these units. One was the mechanism that would get gummed up and jam up like all the Sony VHS that used this chassis. Another big problem these ones had was the power supplies had a tendency to blow up due to bad element capacitors being in them. So I think one of these two machines I changed the power supply on years ago too, because I used to do the maintenance on these things for the fellow that owns these. The guy that gave me these was a guy that I worked in broadcast with for a while there, and he left the industry too and went and started his own production company, and I started my own production company. And right off the get-go, the P5 guide or P6 guide is sticking. I forgot for a minute there that my camera was in manual focus, so if that other shot was out of focus, I apologize. Here's the P6 guide, and as you can see, the grease has dried out. So the first thing I have to do is I have to grease that pin. And we'll see whether looks like, oh, this one here is going to have the blue gear broken too. See that? The gear underneath it is broken. So we know what the problem with this one is. Right now, I need a blue gear. So I'm not even going to proceed any further on this unit at this time. But what I am going to do is I am going to take that blue gear out. And I'm going to take that blue gear down to a local shop that has a 3D scanner and 3D printer, and I'm going to see if he can print me a gear with a 3D printer, and we'll see whether that will fix this one. In the meantime, I'm going to go on to the other slvr5 and see what's wrong with it. So bear with me as I put this one aside for now, and I'm going to get the other one and we'll get it apart. So this is the second machine. Someone's worked on this because it's got the wrong screw stuck in the side here. And it's got the wrong screw stuck in this side cabinet. So this is another one that's probably got some serious problems with it. I mean, I wouldn't have had them given to me if they were working, right? Let's just see what's wrong with this one. In fact, all the screws are the incorrect screws. So let's just see what the damage on this one is. See if this one's got broken gears in the chassis like the other. Well, this one doesn't appear to have a broken gear, and the guide post is not frozen on this one. Let's just see whether this one will actually power up. Okay, let's turn on the power and see what happens. We have no power. This one may have a power supply problem. The power blocks on these units were problematic, very problematic. Capacitors that pissed all over the board were very common on these machines. What the heck? Oh, check this out. Someone's done. They go to unplug the plugs. Like someone's done a little modification on this thing. What the hell is this? This is not something that I've worked on. Yikes. Take a look at this power supply. This doesn't look good. Maybe the power supply from the other one can be swapped in and put into this one here. This is pretty sad, this one. Check out the power supply. Like, what's with this wire that someone just scabbed on there and stuffed into the pin? It's like the pin is burned off. Huh. That's really bad, that. Let's just take the top off this thing and look at the actual capacitors on this thing and see how many of them have blown up. OMFG. Unbelievable. Look at what someone's done to this power supply. And whoever serviced this thing didn't know what the heck they were doing. There's a screw just sticking out through the bottom here. What the? Oh, that's the one I took out to remove it. I'm pointing at these capacitors in here because these are not high temperature capacitors. Somebody has been into this unit and replaced these caps with 85 degree. That would explain why it doesn't work. Looks like someone's changed this little Zener diode down here too at some point. This capacitor over here is all burnt up. It's actually changing color. This power supply needs every cap in it replaced. So that is something that's not going to happen. Not on this one anyway. I'm not going to rebuild this power supply. The other deck, though, I believe has a new power supply in it because I'm pretty sure I put a new power supply in that other deck about 15 years ago. In fact, I might even still have a box. I have a box that one of the power supplies and this came in. Actually, it probably wasn't 15 years ago. It was probably 10 years ago because I wasn't working at the shop at the time. I was working at home, and the guy that owns it brought it to me, and I ordered a power supply, and I think I've still got the cardboard box that the power supply came in with the part number and everything on it because I was using it to store some parts in. I've never saw this machine before, but the other machine is one that I changed the power supply on. Looks like this one's had the capstan bearing replaced on it at some point. It's got the newer style capstan bearing. If I show you the other one, the one with the broken gears, if I show you that one, it's got a different capstan bearing. If you look here, you notice the difference? That's the old style. That's the one that bends. When it bends, it starts, you can see how flimsy it is, right? When it bends, it starts to cause the rotor to rub. The reason why it bends is because the metal here is too thin on the back. If you notice the other one, if you notice this one, this metal is a little heavier gauge behind here. So this one doesn't flex. See, the other one will flex quite a bit. This one doesn't flex as much under the pressure. What I'm going to do is I'm going to pull the power supply out of the other one and plug it into this and see if this one will work with the other power supply, which I don't even know if that other power supply works. One thing is certain though, this one here is blown. And in order to fix that, I'm going to have to change every single capacitor in that power supply. Okay, this is the new one. This was a factory replacement power supply. Looks like that resistor here might have been a little bit warm, doesn't it? It's almost kind of a bit discolored. It's supposed to be green. So this one may have a problem too, but let's see whether this one works before I go any further. Let's see if this power supply actually does anything. Okay, power supply is just plugged in. Let's turn it on and see what happens. What a coincidence. My phone dinged at the same time as I turned on the power. But I have no power. So this one's power supply is not working either. Interesting. Either that or that pin is burned off inside here, and that's why whoever worked on this thing soldered a wire from the third pin over and stuck it into the socket, and that might be why, is that the third pin might not be making a connection. So let's just check that out. I was still recording, I didn't realize it. This is one of these power supplies that when the oscillator is not running, it does not discharge the primary capacitor. If I put my meter across here, this thing hasn't been plugged in several minutes. As you can see, there's still 37 volts. If I put the power on this thing and energize it, we'll see how high this thing charges up. This is why these power supplies are really quite dangerous if you're not familiar with what you're doing, because with the oscillator not running, okay, I just turned the power on just for a second and then back off, and you'll see that this capacitor is going to have 150 volts on it. And that is going to hold that charge for a while because the oscillator is not running to drain it off. So I'm going to have to discharge that capacitor. I'll do that with a resistor. So I just do this by connecting a resistor across the main filter. The value of the resistor is not really that important. I'm using a 2.2K, and that will be enough to discharge this because it's not going to, it's not powered up, so it's going to discharge very quickly. I'm down to 5 volts now, you see. So now I'm safe. And if I want to make sure that there's nothing at that, I mean, I could have just taken my my needle nose pliers, which is what we used to do in the business. We used to just take the needle nose pliers and just go like that and discharge it completely. That way there's no power in it, it's safe. That's the way we used to do it in the shop. I'm doing it with a resistor here just because I don't want to take heat from someone telling me that I'm going to blow parts up by shorting it, which is I mean, I guess it's possible that when you discharge you could. Never has happened to me, but it's always possible. So I did it the right way, using a resistor just to drain the power off. That way this thing is safe now to touch. If I had touched that capacitor when it was charged, you would have seen me jump. Okay, first thing I want to check is I want to check to make sure that the switching transistors here are not, I think this one uses an IC. It's not just transistors, it's actually an IC module. So hopefully that's not blown. So it's a hybrid IC here that does the switching. Hopefully it's just the oscillator's not running, and that's why it shouldn't be shorted, because if it was shorted I would expect that I'd get a short on here and it would have blown the I think it's probably okay. I'm not getting any shorts. I'm seeing the junctions inside here, so I think that's probably okay. And the reason why it's not running is because one of these resistors has gone open that biases it, and it's probably because one of the capacitors on the primary side went bad. That's kind of what I think what's happened on this one. So let's check the ESR on this little cap down here. Where the heck is it? ESR meter is showing that that capacitor is completely open. Let's remove it and check it out of circuit. So here's the cap. It's a 1 microfarad at 200 volts. This is little capacitor's only job is to actually generate a pulse to get this power supply working. 1 microfarad at 200 volts should have, I mean, it should actually could be quite high. It could be as high as 20 ohms for 250 volt. But this one here is completely open. Like nothing at all. This capacitor is completely open. Let's go find a new one. So say the job of this capacitor is just when you first plug it in, it gets a pulse as it charges, and it kicks it. It's the kickstart capacitor basically, or the bootstrap capacitor is sometimes called. Just provides an initial pulse to get the oscillator running, and then it's done. So let's find another one, and I'll of course find another high temperature. 1 microfarad, 200 volts. I may be lucky and have one of that rating. Well, I don't have the exact size, but what I do have is I do have a 4.7 at 200 volts inside one of these Lights of America LED units that one of the LEDs that are in failed on. So let's salvage this 4.7. That'll be close enough to get this thing going. And to show what this replacement ESR is, it's coming in at 3.4. For a 4.7, it should be less than 5, which it is. So this will be just fine. Just getting the new part into the board. Bend over the tabs here. Okay, there it is. It's installed. Now we can just solder it back down. I'm just going to check the value of that resistor. I'm sure that this resistor that's changed from green to yellow, I'm sure it's open. So let's just check it. It's nice that I've got another power supply the same as because I can look at the color codes, because I think this one here, they're probably kind of burned. But let's just see what this thing's measuring. Actually measuring 15.2 ohms. Just grab the other power supply and see what it's supposed to be. So the color code is brown, green, black. So the first number would be 1, the second number would be 5, and the third number would be multiplier of 0, so 15 ohms. So this resistor is not open. And I don't know how many of you remember the actual. We used to have a slang that we used to say to remember the color codes, because the color codes would be from 0 through 9 for resistors is black is 1, brown is, or black is 0, brown's 1, red's 2, orange is 3, yellow is 4, green's 5, blue is 6, violet is 7, gray is 8, and white is 9. And there used to be a saying that was said, and I'm not going to say the one that I learned when I was growing up, because it is kind of nasty, but I will change it to bad boys race our young girls, but violet generally wins. I think you can probably change the race to another word, and that was the one that I learned. It was the nasty version, but and we could change the bad. Anyway, it was a nasty version that I learned when I was in school. But that's how I always remembered it. Was bad boys race our young girls, but violet generally wins. First letter from each of that slang, and you'll remember your resistor color codes forever. That's the same in the telephone industry, which I'm in now. We learned how our color codes went. For our ring colors, it was bell operators get big salaries. And for the tip colors, it was why run back, you varmint. That would be for the tip colors: white, red, black, yellow, and violet for your tip colors. And for the ring colors, it was blue, orange, green, brown, slate. That's your tip and ring colors. I should know that because I have to do that every day, right? But when I learned that was they were the two phrases that we learned to help us remember our pair colors when we were looking up pairs. Anyway, this resistor checks out okay, so let's proceed with trying to power this thing up and see if it will start this time. One thing I'm not about to do is I'm not going to start this thing at full power, because we don't call these things voltage to smoke converters for nothing. If it's going to go Nova on me, I don't want to start it at full power and have it blow up in my face. So I'm going to start it probably around 50 volts. I'll turn my variac down low, and we'll plug, instead of going through my little power bar, because my little power bar I've got over here won't turn on unless the voltage is over 100 volts. I'm going to have to get into that power bar and just jump that relay. It's a I don't know what brand this thing is here. It's a Panamax power bar. But it's got voltage interrupters in it. If the voltage goes above 125 volts, the relay cuts out. If the voltage drops below 100 volts, the power cuts out. So I'm going to get rid of that power bar and put a different one in that doesn't do that. But I'm plugged right into the variac now. And let's see whether this thing will actually start up. I'm just going to start it momentarily and turn it off and see whether we got any charge up on our capacitor here. Probably not, because my power cord fell out. The outlet on my variac is just about toast, and many things don't stick in it very well, and that plug is no exception. I've got my variac set for about 60 volts, I guess. I want to just see if an oscillator comes on here. So I'll turn on the power, and we see what we have. Looks like we have something happening here. Oh yes, we have oscillation. At least we did. Try that again. Oh, it might be that my connection's not being made. Anyway, we had oscillation. That's a good sign. That means that the oscillator was running. So there's our oscillator was running there. It shut down probably because it's not under load. But at least it's not going kaboom. So that means I can proceed to put the, I'm going to check for any bad solder connections, and we'll put the shield back on it, and I'll test it out at full power. But it's not, we don't have any shorts or anything. The oscillator's running, which is good. That's a good sign. So something I always look for is I always look for bad connections around some of these regulators, like the one down here. And that looks like that connection could be cracked right there. So I'm going to resolder some of these before I put this thing back together. I'm just looking under the magnifying glass. I don't know how well it shows up on camera, but some of these ones look kind of flaky. So I'm going to go over some of these connections first before I put it together, and then we'll see if this thing's going to start up. It looks like it's oscillating. It's had the scope hooked up to the primary side here, monitoring one of the pins off of the output IC, the drive IC, and yeah, it was certainly oscillating. So I think everything on this side is fine. I just want to double check everything on the secondary side before I try putting this thing into service. Sounds like there's some action happening. I hear all kinds of sirens. Definitely, these ones are bad. You can see it even on camera. And when I get in there with my little TV camera viewfinder lens and get right in there and look at it, yeah, definitely these ones are cracked all the way around. So we're going to do those ones, and I'm going to look at the rest of the board as well and make sure there's no other ones that are cracked and ready to fail. I'm just waiting for the iron to heat up again because I shut it off there when I wasn't using it. We'll get the iron warm and reflow some of these connections. Iron's not quite hot enough yet. It's getting there. Also going to do these other ones here. I'm going to do all these regulators. These low voltage regulators get fairly warm. They're mounted on heat sinks, but what happens is the heat travels down the leads and heats up the solder. And because the metals are different, the pins are copper. Whoops, I bridged one there, you see. Unbridge that one now. The pins are copper, but solder, of course, depending on the composition, it's either 40% lead, 60% tin, or some of the new stuff has no lead in it at all. But you get it's got a different chemical makeup, and dissimilar metals expand and contract at different rates. So this is why pins that get hot, like in output transistors and output ICs and stuff, this is why solder breaking is such a problem. I know that one is not good, so I'm going to redo this one here. This is why connection cracking is such a problem. Even with the 6040 solder, which is softer and it's not as brittle as the no lead stuff, you still get connections that break just due to heating and cooling on high wattage components, and it's just because copper expands at a different rate than solder. Simple as that. So when you have the expansion and contraction at different rates, eventually over a number of time it cracks. It's like when you get water into the cracks in your driveway and then it freezes and the cracks get bigger, or in the cracks in rocks. That's formed the Grand Canyons, right? You formed arches and so forth as you'd get water getting into the fissures, and then it would freeze, and it would, when it freezes, it would expand and it would break the rocks, and the rocks would fall apart. Well, in this case, we're not talking rocks, we're not talking freezing, we're talking stress from temperature changes of dissimilar metals breaking the connections. So I'm just going to take a quick look at these, make sure that they are not touching, and that everything looks good. That looks good. That one looks good. And that one looks good. Gonna look at a little bit more on the board, and then we'll test it out. So this power supply is an optical feedback system. Here's the optocoupler here. So basically how that works is when the power supply is running, there's light being produced in the LED side of this optocoupler. That light varies depending on the voltage. The higher the voltage, the brighter the light is going to shine. And the light shines across to the phototransistor junction. The more light that hits the phototransistor, the more the phototransistor will conduct, and that provides a feedback loop to the oscillator circuit to change the frequency of the oscillator. By changing the frequency of the oscillator, it causes the transformer here to go in and out of resonance. The closer it comes to resonance, the higher the voltage. The further away from resonance, the lower the voltage. So you change the frequency of the oscillator, that changes the efficiency of the transformer, that affects the output voltage, and that is how the switching power supplies work. A problem with the early Panasonic designs, wait for that motorcycle to go by, that car. Panasonic's earlier designs, they had the reference was on the wrong side of resonance. Say your transformer is resonant at, let's just say, 70 kilohertz. And when you want your voltage to go up, you move your frequency close to resonance. If you want your voltage to go down, you move your frequency away from resonance. What happened on a lot of the earlier Panasonic VCRs with switching power supplies is they were operating on the lower side of resonance. So in other words, to drop the voltage, they would drop it from 70 kilohertz to say 60 kilohertz or 55 kilohertz. And if they wanted to bring the voltage up, they would bring it closer to 70 kilohertz. The problem that happened was when the capacitors in the oscillator side started to dry out, the oscillator started to drift up in frequency. And even though the LED was lit up full brightness, screaming, voltage is too high, lower the voltage, and the phototransistor was conducting at maximum, the components drying up, the capacitors, the electrolytics drying up on the primary side couldn't change the frequency. They were just drifting on their own. And eventually the voltage would get higher and higher and higher and higher with no way to control it, until one day there was a pop and a bunch of smoke. And we get the VCRs in for service, and every IC inside the set had a hole blown in it. We couldn't figure out why. It's like, what the hell happened here? Did this thing get hit with lightning? Nope. Power supply went south. Panasonic figured out that problem pretty quick. They had no secondary protection. The fix to that was to put a Zener diode across the output so that if the voltage went beyond, I think it was on the 12 volt rail, they put a 15 volt Zener. If the voltage went beyond 15 volts, that Zener would commit suicide and dead short, would avalanche, go into a short condition. That would overload the power supply and blow the power supply, blow the chopper transistor out, but it would save the rest of the machine. And of course, in later designs, they changed the operation so that the frequency was operating around 80 kilohertz. And they would drop the frequency to increase the voltage and raise the frequency to reduce the voltage. And that way, when parts started to dry out, the voltage actually started to drop. And we didn't have that problem with the exploding VCRs. But oh, I remember when those caps started to go, I must have had 10 VCRs in a week that every IC had a big hole burned in it, and they were write-offs. And yeah, we were doing a lot of damage control on that. IC 202 here also looks like it's got a couple of connections that are cracked, so we're going to do this one as well. And C208 looks like this one here's the positive pin is not the greatest. Okay, we'll now put the safety barrier back in place. Complete with the impossible to reuse, reusable standoffs. That's it, little clip. There we go. Put that in there. Push that down. That'll keep that piece from coming apart. We'll put the bottom cover on it. This only goes on one way, so I gotta make sure I've got it on the right way. The sides are a little different, I think. Maybe not. Nope, that looks okay. We check for voltages. Okay, we'll turn on the power supply and just see if we've got any voltages coming out here. Oh, my plug isn't working now. There we go. We have 5 volts. As you saw, the power supply is working. Let's go to the other side over here. Come on. There we go. We have 5 volts. Let's put this in the VCR, see whether it's going to work. Got nothing so far. Very funny, very funny. Might help if I plug it in. Now, let's see if we got power. Still got nothing. But I do recall that this is the one that someone had put that wire on pin number 3. So what I'm going to do is I'm going to get this wiring harness, I'm going to steal it off the other machine. Just trace where this goes and pull it off the other machine and replace that whole wiring harness. To do that, I'm just going to release the front panel. And we'll flip up this board and see where that harness goes. It comes up to the front here somewhere. I think it might go to there. But we'll steal it off the other one, because the other machine will likely, I don't know, maybe it'll be the one I end up fixing. It had this is the one that had the bad power supply, but it had everything else looks like it's been fixed on it. The other one had a good power supply. Well, didn't have a good power supply, but didn't have one that had all the capacitors replaced with the wrong values or the wrong types. This is the one that all the caps were 85-degree units that were in there. Well, that's not going to work in a switching power supply, so I don't know who worked on that thing, but whoever worked on it didn't know what they were doing, that's for sure. The wiring harness comes up front here, so I'm just going to unplug this one because this is the harness that looks like it's been damaged. I'm going to go get the one off the other one and we'll plug that in and see if it works. Okay, I got the wiring harness from the other unit. We'll just plug it in here. The nice thing about having 2 identical units is that I got a complete machine full of parts. And what could be better than having a complete machine with identical parts in it? That's a real bonus, that is. Put the plugs in here on the board. Get my power supply back into place. Just gonna plug this in and see whether it lights up first of all. If the display lights up, then I'm onto something. Okay, I have connected the power. The moment of truth. Okay, what we have here is we have a power supply that's starting and then shutting down. If you watch the meter when I turn it on, the power supply will come up and then it's going to shut off. So what probably is wrong is it's the wrong value of capacitor. So I'm going to have to go and break down, drive in rush hour to the shop and buy myself a 1 microfarad 250 volt capacitor. I didn't really want to have to drive in and pick one up, but that's the thing that I'm thinking is the closest one I've got is a 4.7 and it's too high. So it's causing it's starting the power supply up, but it's not just kicking it to get it going, and it's going into a shutdown mode. It oscillates and then it dies. We know that the power supply is working, it's just shutting down, it's going into protection mode. So as much as I don't like the thought of having to drive in at 4 o'clock in the afternoon on rush hour, I guess if I want to fix this thing, I'm going to have to bite the bullet and go and get one. I'm just going to go looking through some of my other boards that I've got and see if I've got one, a 1 microfarad 200 volt cap, high temperature, and if I do, great. Otherwise, I'm making the trip in to get the part to fix this thing. Well, I don't have the part, so I'm going to jump into my electric chariot and blast through all the tunnel traffic using my I can drive in the HOV lane sticker on the back of my electric car. So I'm going to blast in and pick up some parts, and then hopefully that's all this thing needs. Get this thing going, either this one or the other one of the two. we'll be going. Well, now that I've got the correct 1 microfarad capacitor installed, let's see if the power supply will start now. I highly doubt that it will, because usually they're not that critical. If the capacitors went down, the little 1 mic cap, all it's doing is providing a pulse to start it. So I have a feeling that that's probably not going to make any difference. But let's just measure. We'll put our probe on the diode here, and okay, it's still going into shutdown. So I have to do some more tests and see why it's going into shutdown. You want to see something funny? I'm just looking at the 2 power supplies. These power supplies are actually different. They're different power supplies. The capacitors and the resistors are in a different location, but I'm just going to check a few of the resistors here to see if we have any opens here. R103 and R104 are a couple suspect ones because they're directly involved in the oscillator circuit. So let's just take a look at those 2 first to see if the problem is one of those. It's funny because on both R103, I'm getting a voltage warning even though I've discharged the capacitor and the power supply here. It's built up a bit of a charge again. Both these resistors might be open. I'm just going to remove them and test them out of the circuit. I see my other cat has made herself right at home, lying in some packing material. So this power supply that's still shutting down when I start it up, I've just started checking a few of the capacitors, and I've got some here that actually look like they're leaking. If you look at the leads here, like the seals are leaking. You see the telltale sign of leakage? Let's look inside the cabinet here, and you'll see on the board. I'll focus the camera here. There's indications that we've had some electrolytic leaking off these capacitors, and that's more than likely why this thing's going into shutdown. The ESR is actually testing good on them, even the ones that I've pulled, but we're going to have to change a bunch of caps in this capacitor, and this is going to require a complete rebuild, I think, to get this one here working. Big problem with this particular power supply is there's no schematics available for it. Even with the service manual for the slvr5, Sony just listed the power block with the part number and said do not service. So they want you to buy the whole power block. And again, on this particular VCR, this one was changed once. I remember swapping this power supply for this customer on this one. I don't know who got at the other one because I've only worked on one unit for this guy, and it was probably about 10 years ago because I did it here at home, and we changed the whole power supply. He wanted it done. He didn't want to experiment, probably because the other one he had that into a shop, and he had a bad experience with them trying to recap it and putting in all 85-degree capacitors instead of 105. So when this one came to me, the guy that owned it just said, change the power supply. So we did. This one, the whole power supply was changed. This is the new power supply, and it's gone bad too. Anyway, I'm going to pull some more of these caps out here and just take a look at them, but I think we're going to have to probably change the majority of these capacitors in here because this thing will start and then it just shuts down. And it could be the leakage on the board here causing some conduction between the parts, or we may have some other components, but for sure this cap is leaking, and I bet you the other ones are as well. So that capacitor I'm changing, it was it C206. It's here, and I'm putting a 470 high temperature 25 volt. The original one was a 16. So we're going to up the voltage. I'm not going to change all of these caps today because I don't think I've got all of the values, but certainly the ones that are exhibiting any type of leakage whatsoever. And those are typically going to be the ones that are the first filter off of the diode. Those are the ones that are going to take the biggest amount of pounding. Make sure my camera's in focus. I've said it before and I'll say it again. One of the drawbacks of using a camera like this with a large sensor is that you get a shallow depth of field because the iris wants to open up. So it makes focusing challenging, especially when running it in manual focus. But anyway, I've resoldered, or I've soldered in the new capacitor here, and I'm going to take a few other ones that are also in this right off the rectifiers here, a couple small ones here. Even though they test fine with the ESR meter, I'm going to pull them just to check them, because this one tested fine, and if I test this one now, if I show you guys what the ESR on this one that's leaking is, it's fine. I mean, it looks fine. So you can go through and test the thing with the meter, and everything looks good. And then you pull the thing and you find out that the bloody thing's spilling its guts. So this is 470 at 16 volts. 470 at 16 volts should be 0.18. And I've zeroed my meter out here. Now it's 0.11. So going through with testing it with the ESR tester, everything looks good. You think, okay, well that cap looks fine, and then you pull it, and you find that you know, that it's well, you can see it yourself. Check the brand. It's a Nikon. They weren't ones that were terrible, I don't believe. Not like the Elnas. These originally had Elnas. The original caps that were in these original factory ones were all Elnas, and they all blew up. And this is the new style, 105 degree. These ones here also fail. So I'm going to pull a few of the other ones out here. We'll take a look at them and start changing a few of them and see if we can get this power supply working. The next one I'm going to change is C211. Now it's a 0.47 at 50 volts, and I don't have a 0.47. I do have 0.33. So what I'm going to do is I'm going to put two 0.33s in parallel, one on the top side of the board, the other one on the bottom side. That'll give me 0.66, which should be close enough, I think. I don't want to go to like a 1 microfarad or anything higher, because this is actually in the feedback circuit. Right here is the this is the LED portion of the photo opto isolator. So I do want to try to stick fairly close to its original value, because this is actually part of the voltage regulation circuit. So going to a 0.66 probably won't be an issue, but going to a 1 or bigger probably would, or could be a problem. So I'm just going to tack this second one on the bottom side of the board here. So tacking down the second filter like this will give me 0.66. So there's one other small one over here I want to take a close look at that was right in the vicinity where the leakage was. Okay, this one's a 1 microfarad at 50 volts. It's supposed to be with between 14 and 16 ohms. As you can see, it's coming up at 2.9, so 3 ohms. So it again is well within ESR spec, but if we take a close look at the pins coming out of the back of this thing, this one here almost looks like it's also may have been leaking, or if it hasn't, it looks like it's closed too. It just kind of looks kind of gungy around the pins here, like it's ready to start spilling its guts. So 1 microfarad 50 volts, this one's going to get changed to. This one here is C219 on the board there. That one's going to be changed as well. And that one, in case I didn't mention, is C219. Couple more caps on the I guess this is the 5 volt side. I pulled out this 3300. It's checking out good. Might be a little bit of leakage setting in there. I don't think I have a 3300 at 10. This 470 is has been leaking, as you can see from the pins. Come on, camera. You can do it. As you can see here, looks like there's been some leakage. This one actually measures high on the ESR meter. It's a 470 mic at 10 volts. Should be no worse than 0.12 ohms on the ESR tester. This is actually the first cap that I've tested out of circuit, which fails. Everything else has been fine. But this one's coming in at 1.7, 1.8 ohms, and it should be like 0.24. So this one here is bad. I'm going to replace it, and we'll put the 3300 back in unless I can find a 3300, and we'll see whether that will fix this supply. But I'm probably going to have to end up changing all of them. But I'll change the ones that I can see that are bad to start. One thing I've noticed on this unit is that when I first started up, if I put my meter on the LED side between ground and the LED side of the optocoupler, I'll see the voltage rise to about 4 volts on one side, and about 4.5 on one side, and about 3 volts on the other. So the LED should be glowing brightly to tell the power supply to cut the voltage back. That will be shining on the photo transistor side of the photo optocoupler, which would cause this transistor to go into conduction, which should slow down the oscillator. But it doesn't. The oscillator it starts up for a few seconds and then it shuts off, like it's going into shutdown. It could be the hybrid IC itself, I guess, that's bad, although I'm thinking it's probably a connection somewhere in here, or one of these components has gone bad. So I'm just cleaning up. These boards run really hot, as you probably saw the corrosion and flux and stuff that was on here. I'm just cleaning up the board, and I'm going to resolder all these connections in there that look a bit flaky. I've already done the majority of them, like R107, for example, R106. And actually, when I was soldering these pins, and I had to get them really hot, the solder did not want to stick very well, because these resistors here have gotten pretty hot. That's this one down here. These have gotten pretty hot when they're running, and that's just the nature of the beast of these power supplies. They run really warm, as was seen by the scorching of plastic guard. That's just from components making contact. So these things do run pretty warm, so it wouldn't surprise me if it's just the solder connection's broken and it's lost one of the voltages in the control voltage and it's going into a protective shutdown. It could be the hybrid IC, but I really doubt that it is, because normally when these things blow, they short and pop the fuse. They don't go into a shutdown state. But that's where we are right now. I'm just checking all these components in this feedback circuit here. So the more I test this power supply, it leads me in the direction that this hybrid IC, which is where the regulation takes place, is a good chance it is bad. So I'm thinking maybe what we'll do is we'll recap this one that has got all the wrong values of caps in it. Maybe that will be the project. We'll just recap this other one and see if we can get this one going. I guess I technically could pull the hybrid IC from this one and put it on the other one over here, but maybe we'll just recap this this power supply and see whether this one is workable. They aren't even the same. They're slightly different. The parts in them are different. Like, this is a different design. They look the same, similar, but like the location of parts is different. Either that, or maybe it's just someone's put the wrong part. They put a larger one in here at some point. That's probably what it is. That's why it looks different. Someone's put a much bigger cap in here than on the other one. Anyway, maybe I'll get an inventory of capacitors. I'll take an inventory of all the caps in this thing, and we'll go get a bunch of caps tomorrow and recap the other one. See if we can get it to stay on, because this one comes on for like a second and then it goes off and it's going into shutdown. The feedback circuit seems to be working, so I've got to think that it's maybe the hybrid IC itself is packing it in. Something's not right, but that's why I say it's nice to have a second unit here. So maybe tomorrow, when the stores are open, I'll make the trip in, I'll take an inventory of the caps I need, and I'll get a series of caps, and we'll spend some time recapping this one and see whether this one will work. This is the one that's got the plug that's broken off of it too. That's why someone broke a pin off this one. That's why they've done that. It's because they broke one of the pins. Someone who worked on this one. But I think they're the same other than that. So let's see what the part number is on this thing here. Oh yeah, it's a different part number. This is the 413-566-11. This is the 413-566-12. But they're both HS31 SUs. Just that this one was a newer one. That's the plan. Okay, so I'm back onto this power supply for this slvr5. Again, I've just gone and picked up a whole bag full of parts here. I'm going to change every capacitor. Now this is the one that somebody had put all the wrong values in. The other power supply has the drive IC that's got a problem. So we're going to work on this other one here that had all the bad caps, because I don't know what shape the IC's in, but this one here shuts down. And then I ended up having a problem with my Variac shorting out on me too, which could have created some more headaches for me, but we'll change all the caps in this one here, because the other one, it goes into a shutdown state. It starts up for a few seconds and it shuts down. It doesn't appear that we've got any type of control, any regulation control. So I'm thinking maybe the drive IC, but we'll change all the caps in this one and see if we can get this one going. All I really care about is if I can get one of these power supplies working, because if I can get one of these Super VHS machines working, at least I have another one full of spare parts, right? If I can get both power supplies working, then I can try and get another gear, because the other one's got the blue gear that's broken. So it'll be kind of interesting to see if I can get one 3D printed that would work. I know it's under a fair bit of stress though, because of the little spring that's on there, but anyway, this one here I should be able to get this working. I'm going to start replacing all these caps. We're going to change every single cap on this power supply and see what we can make of this thing. So as you can see, I got myself some new solder wick, because I was getting pretty low on the other stuff, and this stuff works pretty good at taking off solder. Even though I've got the solder vacuum pump, this stuff's a little quicker. Oh, I like this. Static free. Yeah, I would hope so. It's made out of solid copper. So work is underway to change the capacitors in the power supply. I've done the little 1 microfarad 200 volt. I'm now working on the secondary capacitors, and hopefully that's all that's wrong with this power supply. Got a few to change. Take a look at some of the ones that came out of it here. Here's one of the ones that came out. It's supposed to be a 1200 volt or 1200 microfarad at 10 volts. Someone had put a 16 volt 1085 degree cap in there, and the other one was, this was supposed to be a 1 microfarad at 200 volts, and somebody had put a 1 microfarad 350 volt cap in place, and this one's all dried out. It's discolored, it's gotten so hot. I don't know who did the work on this before. It'd be interesting. I'm sure that the shop that did this work is probably no longer in business, as so many of them have shut down, but this is the type of work that we used to see when at the shop that I worked at. We would see stuff that would come in that had been to other shops, and we used to get to see this type of work all the time. Say somebody's repaired that connection there, the trace has been damaged and someone has bridged over, but anyway, hopefully there's no other damage. I know that there's like you can see where the electrolytic's been, where the caps have literally oh man, I don't know, maybe I'm fighting a losing battle here, but you can see where the electrolytic has actually leaked out onto the can here. These power supplies were something else. They were really bad. Like this is one of the worst ones. Was these? Looks like that heat sink's not. The spring clip here is not even holding this IC down properly. There, that's a little better. I don't know. I hope not just it's not just a futile experiment here, but we'll see. That's why originally I wanted to try and get the other power supply working, because I thought maybe it was in better shape than this one, but it appears to have a drive IC problem. I guess the worst case scenario, I could pull the IC out of this one to get the other one going, but let's see if we can get this one going by changing all the caps in it. The next cap I pulled out, somebody again stuck a 1 microfarad 350 volt cap in there. This was supposed to be a 1 microfarad at 50 volts. A little bit of a difference there, so let's find the right size one and we'll replace it with the correct size. I'm pretty sure I got some ones at 50s. If I didn't get some, I should have some. It's a pretty common size, but 0.47. Here's my ones at 50s. This is our one at 50 right here. So we'll replace it with that one, and I'll show you a trick with the solder wick, because sometimes it gets kind of dry and it doesn't want to suck up the solder that well, and you can rejuvenate it by just dipping it into your rosin flux, and that'll give it some more. That'll give it a little more sucking power, as to say. So next I'm going to remove C206. So I just want to give my rejuvenate my solder wick. So I'm just going to dip it into the rosin flux. Let the rosin flux get into the braid, and that'll give it a little more suction power for taking off the solder. So the next one is this one here, which will be C206. I can just lay this thing down on here. What's happened is this solder is getting kind of dry. It's probably got a lot of the electrolytic leaked into it from when these caps leaked. So this, just by doing this, freshening up the braid, and this is old braid. My new braid that I just bought probably won't have this issue, but this braid that I'm using here is probably 10 years old, if not older, and it's getting kind of dry. So that's just a way to freshen it up a bit, and it'll lift the solder right off. So then the capacitor or component that I'm going to change, I can just turn it over, just grab it, and it'll lift right off the board. What did they put in this one here? Oh, somebody actually put a 105 degree one in. It's a Wendell capacitor. Gee, I wonder who sold them. Well, that one's getting changed out because I'm doing them all. I think there probably are a few in here that are 105 that are probably okay, but definitely the 85s have got to go, so I might as well change the other ones at the same time. There's not a lot of room inside here. There's not much room for error either. Very tight fit, and I just noticed that someone's replaced a resistor, and there were some jumpers, I guess, that were corroded due to leaking electrolytic, and they've been replaced with jumper wires. Hopefully they're okay. As I think I mentioned earlier, these power supplies were never intended to be repaired. Sony didn't publish any data on them, and there was no parts available for them. They were supposed to have been replaced as an entire module, which is the other machine that was part of this guy's collection. The same guy gave me two machines. I worked on his other one about 15 or so years ago. Maybe not quite that. A dozen years ago anyway. And I replaced the entire power supply for him. And it's gone again. But this one here had been serviced at some other shop. And whoever did this service didn't have a clue as to what high temperature capacitors were and why they're needed in this switching power supply. And they changed them all. These originally had Elnas in them and they all leaked. But whoever worked on this just put a bunch of these cheap, what are these, Rubicon 85 degree Probably because they didn't know any better. You know, when the high temp caps came out, a lot of the techs didn't know what the heck they were for or why they were different. When switching power supplies first hit the market, and you had to use high temp caps, a lot of the servicers didn't really understand why they were different, and they just used what they had, and the ones that were readily available were all 85 degree of the day. Another fine example of incompetence. Someone put a 3300 at 16 85 degree capacitor. The original was a 1500 to 25. So why would you go from to a 16 volt capacitor? Actually, the original one might have been a 15 or 16 volt, but still going from 1500 to 3300, that's a little too much. I mean, you can go a little bit up, but to go that high, that's... I mean, in theory, it probably would work, but the problem with going to that size of component is that your inrush current, when it starts up, is going to be a lot higher. And these things run pretty close to their limit anyway, so having a much higher inrush current when you power it up, it's going to take a lot more energy to start one of these things up, which could result in the power supply going into shutdown before it even starts. Okay, that's it. The last capacitor is now soldered onto the board. Now I'm just going to clean up my workspace a bit here, and we'll test this thing out and see if it'll start up. Check this out. This board's been corroded. Make sure my power's not on. Right there. Look. Put the meter across here. So from my power input, here's my AC input, these two sides here. From here to here, I've got continuity. This one here goes up to that, and I got nothing. Whoops. See? Nothing there. This side here, I've got continuity. This side I got nothing. It's right in here. It's burned. I have to repair that. You can see right here where it's sputtered off. So I have to replace that with a piece of wire. I mean, that's just the damage that this leaking electrolytic did on these power supplies. It's just a joke. As I continue to inspect this board, check out right here, this connection here. I'm going to just move the resistor on the other side. You'll see it wiggle. Where is it here? I'd say that connection's broken. What do you think? I'm checking this whole board before I power it up. I'm going to look at everything just to make sure there's no connections that are broken. I don't need this thing turning into a voltage to smoke converter, if you know what I mean. So if I fire it up, I'm getting exactly the same results as I get with the other one. With this one, when I turn it on and watch this go, it comes on for a second and it goes off. So this power supply is now behaving exactly like the other one that I suspected that the IC has gone on. So maybe the IC is not gone. I have to do some more investigating on this one and see what the heck is causing this thing to go into a shutdown. It comes on and all the voltages come on for a split second. Like for example, if I measure my the capacitor will be charged now. This is on the, where is it here? Oh, this is on this is the negative supply for the display. And it's got like minus 61 volts. Right, the capacitor is still charged on the secondary side. So my secondaries are coming up and it's just shutting off. So it's either going into an overcurrent shutdown or an overvoltage shutdown. So we're still working on it, but now I have two power supplies that do exactly the same thing. So one thing I always disliked about this design of power supply is that if the oscillator stops, the main filter capacitor is going to stay charged. So what I've done is I'm just putting a small resistor across the main filter, and I've just picked an 82 k ohm, something that'll discharge it. So if I just fire this thing up here for a moment here, you'll see that the voltage will rise. If I don't kick my camera out of the way, voltage is going to go up. I'm only powering this thing up with about 25 volts too, so I'm not powering it up at full power right now for testing. But if I power it up, if I power it up, you'll see the voltage will go up. If I shut it off, now this resistor is going to drop the voltage and it'll take a minute or so for it to drain out completely, but that way it keeps the power supply safe. I probably went a little high. I just picked a value of resistor that I had, probably more like around 10 or 20K would be more the size of resistor that will discharge the voltage, but this will take it down to 0 without drawing much power, and I don't want to dissipate much power through it. It's only a small 1/4 watt resistor, so I'm keeping the value relatively high. As you can see, this will make the power supply safe. It'll discharge the power from the main filter, and that way you don't run the risk of getting a shock. So we watch the scope as I turn it on. You'll see it starts up and then it goes off. We have no regulation, and it's doing exactly the same thing as the other one is doing. Better discharge that capacitor before it blows up, because our negative supply, which should be I think around 30 volts for the display, is going up to like 60. So the voltage is going way too high. Now I'm able to check the voltage going into my optocoupler, and it's should be lighting that LED up bright as anything to say slow that power down, bring that voltage down. It's way too high. But we're not getting control on the feedback side. So I got to concentrate back into this circuitry here. I'm just letting this thing discharge here because the power supply will still be a bit warm here. The capacitor will still be charged, but my little resistor that I put across here will take care of that, dissipate that charge in a minute or so. But I got to now look into this circuitry here. Either we've got a connection problem or we've got a component that's gone bad. Although everything I've checked, it doesn't appear to be bad. The resistors are all the right value, unless there's a trace that's damaged. So I got to look at that. Or we could be looking at a bad IC on this one too. Could very well be that this bloody IC is no good, and that's why it's shutting down. And as I say, the other one is doing exactly the same problem. It's just I turn it on, it comes on, and you get the waveform on the scope just for a second, and then it drops off and it goes into a shutdown state. So both supplies now are doing exactly the same thing, but this one's had every capacitor replaced in it, and we're still at the same problem. So this one's becoming a hair puller, and it's going to be interesting to see what actually is what is causing the thing to shut down. So I'm just doing a few tests on a few diodes here. Came to diode D207, and D207 is giving me some strange readings here. Like it's saying 0.193. It should be like 0.7 volt. But I'm getting readings the other direction too. I'm just going to pull this diode out and make sure it's not being influenced by other components on the board here. So I'm going to try this power supply connected to the unit itself. All my voltages, the power supply shuts down still. It fires up and it shuts down, but I think it probably is because it's not being loaded down. So I'm going to try hooking it up to the VCR itself and see whether the unit will boot up. Now the other one would not boot up, the other power supply, this other one here. This one it won't boot up on. So this one has a problem, and I think it's probably the hybrid IC is bad on this. But this one here, I've changed all the caps on it. I've checked every component, and it looks like the components all look fine. So let's just see, let's put on the power here and see whether we can get anything. Oh, that's a good sign. Power is turned on. We're only running it at about 60 volts right now too. Let's see if this thing will actually play a tape. What do you think? Okay, so it loads. It's not going through the loading cycle. Now it is. Okay. Sounds like that capstan motor is a little bit rough. I'm not getting a picture. Let's just try the TV here and see. I'm not getting any video. How about sound? Okay, I have no picture, but the unit fires up. And that's a good sign. That's It's a very good sign. So have to investigate and see why I don't have a picture, but at least, hey, the power supply is working. So all that work, changing every single one of those capacitors on there and doing some work on the traces that were damaged, appears to be paying off. I may be still missing a voltage or so, voltage or two, because I have no video, but hey, the thing's not blowing up. The power supply is running. My motors are working. We're getting there. We're getting there. This machine is going to be working, and it should be working fairly soon now. Now that we've got, at least we've got it turning on, right? Powering up. I just have to figure out why I've got no video, so I'm going to do a little inspecting on here and see if I can see anything obvious. After measuring the voltages, maybe one of my 12 volt supplies is not there. I do have a 12 volt supply, but I think there's probably supposed to be more than one. I'm just going to take a look and see what voltages are supposed to be where. Let's just take a look at the head preamp and see whether there's any RF coming off the heads. I see my tape counter is moving, so it's playing whatever's on this tape. Yeah, tape counter's moving. Let's just see if there's any RF off the preamp here. That'll tell me whether we've got signal being read off the tape. Looks like there's something there, doesn't it? Where's my test point? Yeah, I think you can probably see the scope there. We have RF. So that part's working. I've just got no video coming out the video output, so I may be missing a voltage. I'm just going to see if I can find what the pinouts are and what voltages, and see whether I'm missing a voltage. Ah, my visitor decided to come and pay me a visit. That would be that one. So it's been hiding in here under my bench all night. Okay, some testing, and I don't have a manual for this thing, so I've just been looking at some of the connectors on the board. And down here we have our power supply voltages, like we have our switch 9 volts here, and you can see we've got 9 volts. One I'm missing is I've got my 35 volts here, which is a little high, 38, that's good enough. I've switched minus 6 volts. I'm getting minus 1.6. So here's our problem. The switched minus 6 volts is missing, and that's needed by the digital circuits. This has got digital signal processing for the picture and crap that this had for the editing thing. This is kind of marked up. This, I think, probably what I'll do is when I get this working, I'll take the faceplate from the other one that looks to be in better shape than this one. But my minus 6 volts is missing. In fact, I may end up fixing the other machine. It's mechanically better. I know the other one's got a broken gear, so I can probably take the gear from this one. So say once I get all the voltages there, I'll pick which machine I want to keep and just kind of got one for the other. But this has got the newer capsule motor. My minus 6 volt supply is missing. Now this connector here, I believe, goes right up to the power supply here. So if I count like for like, I should figure out which lead. So pin number 1 on this is, I'm just looking to see which one's which. That's the 8 volt supply, so that's that one. That's pin 13. Okay. So 5 volts should be this one here, which it is. Ground is ground. So 13, 12, 11, 10, 9 should be 35. 8 is my minus. It's pin 8. Yeah, pin number 8. Starting down here. 5, 6, 7. This should be pin number 8 here. And it is low. So that's my supply that's missing. So all I have to do is just trace that back and see where it goes. And I believe that goes to IC 206, which is right here. And I have minus 1.3. So this is where my voltage is missing. and I have nothing on pin number 1. Pin number 2 has got -3. What is pin 1 from? That's grounded. So -3 is here. It's coming off that. Q204. Ah, -10. I think Q204 might be shot. I got -3 volts there. Let's just test it. Q204. Let's see if it's gone open. That's a regulator transistor. The big problem with leaking capacitors, when they leak and puke their guts onto the board, is that a lot of times you'll end up with damaged traces on the board. And here's an exact case of a good example of damaged traces. Fortunately for me, I have another power supply here that's not quite as badly damaged, so I can actually still see the traces. But here we go. We're missing a supply. It's coming off of D202, and trace it through, and it goes to this capacitor over here, and I've got no, whoops, you can't see what I'm doing, I got no continuity. But if we look very closely at the board, you'll see that there's a break right there. So, I think if I put a jumper wire in place of that, we may have liftoff, as they say. So let's get a piece of jumper wire, and we'll replace that broken trace with a piece of insulated wire. I'm not too worried about the music playing in the background. I'm just rendered out a video, and it was testing on playback, and it's all royalty free, so the music that's playing in the background while I'm working on this piece of junk is not going to cause me any problems with YouTube. Shouldn't anyway. Okay. Shall we power this thing up and see if anything works? Watch it go kaboom. Okay, power. I'll turn it on. And I think we're going to have some, we're going to be in business this time. And I'll tell you the reason why I think we're going to be in business, because I have my on-screen display. Load up the tape. Let's see if this son of a bitch plays. Play. Okay, I'm not going to say that this one was an easy fix. This has got to be one of the most involved repairs that I have done on any VCR in forever. This was... I had to repair multiple traces on this board, and I had to replace every single electrolytic capacitor on this board. Now, one of the reasons I was able to succeed without a schematic, obviously, is focus. One of the reasons I was able to succeed was because I had another power supply. This power supply, I think probably what the problem is it's the hybrid IC, the regulator IC down here, it's cooked. Because it will start and shut down. Start and shut down. Like this one was doing after I changed all the caps, but under no load. It would start up and then shut off. And this one was doing, the other one was doing exactly the same thing. But when I plugged it into the machine, it wasn't doing anything. It was doing exactly the same thing. It would try to start and then it would shut off. It would try to start and it would shut down. That kind of threw me for a bit when I was working on this one, and I think I mentioned earlier in the video that I had the same symptom. I did, but that's because it wasn't loaded. As soon as I put the load down on this one didn't shut down, so I just didn't have video because I was missing a voltage. I was missing my negative 9 volts or 6 volts or whatever the hell it was, minus 6 volts. But it's a 12 volt supply over here that actually biases. I had to trace it back, and it goes through a Zener diode over here, and then it comes back around and biases on that regulator transistor. A transistor tested okay, so I didn't have to change it. The next thing, of course, will be to try and get that hybrid IC for this. I'll see if I can get this one going at a future date, but I'm pretty stoked. I have a Sony slvr5 Super VHS machine that is now working. Yes, 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 yes. I don't know if you guys want to see me put this thing together. I don't think that's necessary. This video has gone on more than long enough. Maybe I'll make a test recording and make sure it records, and then we'll sign off. Oh my gosh. I have a standoff. I heard growling. I heard growling behind me, and I've now got a standoff. If you guys notice some stuff sitting on the ground there, this is stuff coming up for a future repair video. I have a mixer that's going to be repaired. I have a 3/4 inch machine down there that I'm going to take a look at. And there's even an old 16mm film projector sitting down there on the floor. But we're having a showdown here. We could have some entertainment here momentarily. Let's just see if we hear any more growling. Jinxie keeping your distance? And you know what's going to happen, right? As soon as I turn off the camera, there's going to be some action. One's going to swat at the other. Usually the Siamese on the right chases the other one all around. It's funny. That's right, have a standoff. This could go on all night. See what I mean? So some of you have asked me how I can generate color bars and make my test tapes. This is exactly what I use. This isn't the only camera that I've got that's got color bars on it, but this is one of the ones here that I use. I'm actually going to do a shootout video at some point and compare a couple of different cameras. This camera is a piece of junk, okay? The tube is shot on this camera, but this is an old one. It's an old Sony, it's an old broadcast camera, right? This is one of the ones that I used with the portable Beta, the Beta 1. I actually had the big brother to this one as well. I had the M3, which was a 3-tube. This is a single tube. This is the, what is this one? This is the 1800, I believe. What's the model number of this one here? It's DXC 1800. It's the same camera as the 2800, but it's the professional version. The 2800 that I did the little demo video with there a couple weeks back, where I beat the crap out of an old tape deck. That's essentially the same camera, but the tube on this one has got a problem. So I didn't use this one, I used the 2800. But this is actually a step up from it, but it's the same type of quality. Anyway, it does generate full field bars, so that's what we're going to use it to do. See, if I put it in camera mode here, I mean it works, but the picture quality of these things isn't very good. You see what I mean? See the ring in the middle of the tube, in the middle of the screen? The tube is screwed. So I'm going to do I'll do a shootout with this thing at some point in the next couple weeks. I was thinking what I was going to do is I'm going to set up a bunch of analog cameras and do a shootout between the different ones, and we'll record it all onto digital tape. It'll all be done in standard definition. And to be fair, I'm not going to use a VHS or a beta recorder. I'm going to record it straight to DV. That way, the various cameras, and I've got a bunch of cameras that I'm going to set up and test, so we can actually look at the difference in the quality between Vidicon, Satacon, CCD, CMOS, and anything else I can get my hands on to do some testing. And that'll be coming up soon. Anyway, I'm going to do a test recording of color bars on this thing. So there's the color bars plugged in, and we'll just hit the record button here. What speed am I in here? Speed, SP, EP. I'm going to do it in both. So there's EP, so there's SP. So I hit record, and the machine backspaces and starts recording. I'm not recording sound obviously here, and I'm not recording this in Super VHS. I'm just recording it on a standard VHS tape. Just put some bars on here, and I'll do a bit of recording for maybe 30 seconds, and then I'll switch it down to the EP speed, and we'll see how this thing goes. So about 23, 24, 25, just look at the tape counter here, and it comes up on screen too. And I guess I have to hit pause in order to switch this thing down to EP. There we go. Now we're down into EP speed, and I'll record a few more. I'll record another 30 seconds in EP, and then we'll play it back. And then that'll end this video, and I'll put this thing together. And as I say, I think what I'm going to do is I'm going to take the bezel off of the other one because I think it's in better shape than this one. And I'll put this whole thing together tomorrow. I've spent way too many hours on this machine getting it going. But and I ended up, as you can see, I ended up fixing the power supply that was actually in worse shape only because I didn't feel like swapping the hybrid IC from one to the other. Okay, we've done a minute. We'll rewind the tape here. There's our playback, complete with VHS noise. VHS isn't great. It's terrible, actually. And it's even worse when it's played back on a, like if I put that on an analog monitor, it would look better. But any VHS that's played on digital decks doesn't really look great. A lot of chroma noise in there. Maybe we can tweak that out. In fact, that'll be the next thing I'll be looking at is, can I improve that picture? Because that's looking pretty sad. There's EP. A lot noisier, as you can see. But the auto tracking's just kicking in. But yeah, that's pretty noisy, that picture. Maybe we'll look into that. I'm going to plug this into an analog monitor and see what it looks like. But that picture is actually quite, chroma is quite noisy. So maybe we'll do another video before I put this thing together. I'll see if I can find out why the chroma is as noisy as it is, because yeah, it's pretty bad. Especially compared to the original. Just want to see what it looks like on an analog monitor, because as you know, the digital monitors generally it's not as bad on the analog monitor, but it's nothing to write home about. Although color bars are always the hardest thing to record anyway. They tax the system, but anyway. That's it for this recording. That's it for this video. I think maybe I'll do a second video on this. I'm going to put the power supply back together and get all the shields in place. And then I'll look at the video board and see if there's anything on the video board that needs to be looked at. Because that chroma is pretty noisy. I may be able to find some caps going bad in the video circuit. But there we go. Power supply is working. Hope you enjoyed this video. It's dragged on for far too long. I hate doing videos that are this long. I mean, I'm going to cut a lot out, or have cut a lot out of this video, but literally I've probably got 4 to 5 hours of work on this machine to get this machine back to the condition that it's in now. And we're getting there. We're not there yet, but we're getting there. But I can see the light at the end of the tunnel now. I'll hit the eject button here and you'll see this tape unthread. What I may even try, and this might be worth something, maybe I'll do a video on this, I may even try pulling the gear out of this one and the capstan motor, because it's the newer one, and putting it in the other machine and see how the picture looks on that one. Maybe that's something to address, see which one's got the best picture, and go from there before I start tearing into more circuitry, especially without a manual, right? Anyway, hope you enjoyed this video. We'll catch you in the next one. Bye. So here's a follow-up video to the slvr5 that I rebuilt the power supply on. I've now got the power supply unit mounted. You can feel the heat coming off this thing. You can see the vents. All the capacitors face in this way, right? So it does have ventilation to cool it. The power supply is now mounted, and that's made quite a difference in that chroma noise that we were seeing. If I make a test recording, for example, here, and let's put it into SP first. Where's my speed? Speed, SP. We'll reset the counter using the remote. Okay, I found a remote for it too. So we'll make a test recording in SP and EP, and you see all that wonderful noise that we were seeing in the chroma is pretty much all has been taken care of. What was causing all that noise was the fact that my power supply, which had no shielding on it, was sitting right over top of the video board. So we're getting a lot of induced noise from the power supply itself. The unit still does have a problem though. I've just noticed that it's not recording in hi-fi sound. I haven't checked to see whether it's playing in hi-fi. That'll be the next test, but seem to have a hi-fi sound problem. but I'll show you the picture. So there, I've just made a quick test recording here. You can actually put it into EP as well, and I'll record another 20 seconds in EP and rewind the tape, and you'll see that it's actually going to look a lot better than it was looking even on the plasma screen, which plasmas aren't the best for handling the time-based errors that you get off of VHS especially. Okay, so we'll rewind this tape. And as you can see, our color noise is far less than we were getting last night. But the lines are never going to be perfect off of VHS, and there we go down to the EP speed. Color's not quite as clean on EP as it was on SP, but it still is not bad. I'll show you the little analog monitor here as well. It looks a lot better. So here's my slightly defocused picture, because if I focus it too sharp, you're going to see all the lines on the from the tube. So I'll just defocus it slightly. So there's SP playback, and it's going to switch down to EP right about now. And as you can see, that's actually not too bad once the tracking kicks in. Analog tube can certainly handle the timing errors better than any plasma, because of just the way plasma works. So saying that, the picture is actually quite good now, and now I need to deal with the sound problem. So that's what we're going to try and address on this video, is the sound problem. Why is it not recording hi-fi? So we'll first put a hi-fi tape in it and see if it will play it. Now, one thing that was kind of unique about these Sonys is that it was the full load system, so when you rewound or fast forward, the tape stays loaded. But they did have a mode called high-speed rewind. You could press high-speed rewind, and it would actually unload the tape, and then you could rewind at a much higher speed. And that's something that was kind of unique to Sony. Some of the other professional machines would do a half load where they would unload to go into rewind, and then they'd have to thread up again. But Sony actually offered a separate button called high-speed rewind, which you could use. You could use when you wanted to rewind the tape quickly. I'm just testing this thing out to see where our problem is. It looks like it's not playing back hi-fi either. It's I can select. What's happening? What's going on? I can select the output audio monitor, but it doesn't appear to make any difference whatsoever. It's and I also get this click. Listen. So something in the audio circuits give me some trouble in this. I'm going to do a little bit of investigating and see if I can figure out what's causing it. Here's the main chassis flipped out. One of these boards is going to be the audio board. Just looking to see which one it is. It might be this one here. I think this might be the AU board. I'm just looking to see. This is a tuner board here, and IF board. I believe this one's video down here. Pretty sure one of these is the audio board. I'm just going to take a closer look at it for the hi-fi audio. Now, once you release the catches, you can actually fold these boards all the way. This is the character generator board here. Here's our tuner and IF board, and this might be the audio board here. Unplug it and take a look and see if I can see any HF9. Yeah, this one's going to be the audio board. I'm going to take a look at it and see if I can spot any leaking caps or anything out of the ordinary on this thing. I think we can see the answer to that question. Look at around here. Okay. You can see corrosion on the board. So you look at the traces here. Look at this trace here. Has been eaten away. These stupid caps. Like these are these Elmas? No, they're Durorex. These freaking caps. There's Elmas on here too, but these purple caps here are leaking. You can see it on the board. So this is going to need a cap job. What I'm going to do, I've got, let's just say I've got an identical slvr5. I'm going to pull the audio board out of that and just do a whole board replacement and see if that'll get my hi-fi audio back on this thing, rather than go and buy a bunch of caps. So that's the nice thing about having two machines. When you've got a donor machine, you can just swap a board. So I'm going to swap the board over and see if that'll fix my hi-fi audio problem. So I got the other board out of the other machine. You know what, and looking at this one, it really, I mean, well, I guess it's not in as bad a shape, but it's got leaking caps on it too. So we'll try this one and see whether it fixes the hi-fi audio problem. It looks like I'm going to have to recap the board on this thing. It's a single layer board, so it shouldn't be a big deal, but I'm going to have to get replace some of these caps. I don't know if I've got the right ones here. 10 microfarad at 25. Yeah, these are Elnas. This one, yeah, they're all Elnas. They're Elna Durex. We'll plug this board in and see if it makes any difference to how this thing's working. It probably won't make any difference, but we'll try it and see. Nice thing about these is they're easy to service. Snap them in. Plug it in together here. And as I said I was going to do, because the other one, the front bezel is in much nicer shape. As you can see, this one here is not all beat up like this one. So I'm going to put the nicer faceplate on this one and put the scrap one on the one that I'm going to just keep as a parts machine. Snap that on. Let's plug it back in and test it. Where's my picture? Did I unplug something? Well, it appears that this board's in worse shape than the other one. I'm not even getting video through it now. I'm getting no signal. So we're going to go back to the other board that is at least passing some signal. And I'm going to have to rebuild it, simple as that. I'll have to replace all the caps on there and fix the traces up that are damaged on the board. So we'll just flip up the clips again, remove the second bad board. I want to make sure I get my picture back before I do any more work on this thing. Yeah, I got my picture back. Yeah, so that other board's obviously got, that other board's got more problems than this one has, so the one that's in here is going to get rebuilt. So when I pull that board out, I'll start looking for capacitors and see whether I've got the values that I need. I might have the ones I need in stock, and I can go ahead and replace them. So looking at this board, it looks like I've got some 47 at 25, 16 at 100. It looks like most of them are 47, and some 10s at 25. 10s at 25 volts, I should have those. 16 at 220, I should have that. And looks like all these purple Elnas have got to get replaced. Typical Elna crap, right? These shit capacitors. Okay, let's go looking for the parts. Going through the parts bin. I do have quite the inventory of caps because I've been buying some lately, so I should have enough to replace these with. I don't know whether these Duro-X mean anything, or whether they're just standard. What's temperature are these? These are only 85-degree caps, so some of them, the leads are actually, get a load of this one here, the pin's actually corroded right off of it. This one looks corroded off too. Incredible. Take a look. The lead is actually burned right off. The electrolytic is leaked and it's corroded right through the pin. So let's change some caps. What do you think, huh? Make this thing work like $1,000,000. Well, I thought I had all the sizes I needed, but I don't. So tomorrow after work, it'll be another trip back to the parts store, and we'll get the right parts and replace all these dud caps on this thing. I want this machine to work like a brand new machine, and when I'm done with it, it's going to work like a brand new machine. That's the goal. The picture already looks good with mounting the power supply back where it was, as you saw. That's taking care of the color smear problem. So now the only problem remaining is getting the hi-fi, and SVHS works too. I've already tested that. Now it's just a matter of getting the sound working. So new parts, and we'll deal with this as soon as I get the parts in. Okay, another $10 in parts. Let's start putting all these caps on the board. I'm going to change at least all the Elna caps that are leaking. As I showed you before, some of these are just the legs have broken right off them. So I'm going to go ahead and change all the caps, and then hopefully that's the only problems that this unit has. I think if we can get the sound back. The picture was looking pretty good when I did my test recording. We'll do some more tests on the thing and see how it looks. But just letting the iron warm up here, and I'm going to go and change all these capacitors out. So the first cap to go in is a 10 microfarad at 25. And I'm going to have to probably do some cleanup of the board here as well. Some of the traces here are pretty grungy. I don't know whether the solder is going to stick very well to them without doing some repair, but we'll try. See whether we can make it work. Okay, doing the next part, I've noticed that the trace is burned, so I'm going to have to tack the negative lead down to where the trace connects, as this one here is there's nothing left to solder down to. Yeah, that's burned right off. So I'm gonna have to bend the lead over and tack it down to the next component that it goes to, which looks to be the wiper of RV007 right here. We'll just check for continuity to make sure that my lead is connected to the wiper of RV007. Right over here. That beep indicates that it is connected. So we can move on to the next one. A lot of the traces here are in not too good a shape. A lot of them are lifting off the board. They aren't broken, but they're lifting, so to be kind of careful when I solder them on that I don't damage them any worse than they already are. Biggest problem when capacitors have pissed onto the board is that it damages the electrolytic is corrosive, and it can damage the copper quite easily, which makes getting a good connection sometimes difficult. Moving on to the next two capacitors. Remove the old solder with solder wick, even though it's difficult to remove it because it's been contaminated with electrolytic. It's still try to get what we can off the board and not damage the traces. Sometimes when you get into situations where you've got corroded solder, it sometimes makes sense just to put a little fresh solder on to try and get rid of the oxidization and dilute the mixture a bit. Get some fresh solder to stick down there and then use the wick to remove it. This is one of the reasons why most shops that were in the business would write this unit off as uneconomical to repair, because the amount of time needed to change each of these little parts would could cost, if this was going into a shop, well, considering the amount of time that was spent fixing the power supply and then to have to fix the audio board, I mean, this would be a couple $100 repair minimum. And consumer electronics is in most cases not worth putting the kind of money in that is required to restore this thing. The reason I'm doing it is it's my machine. If this was a client's machine, I doubt that they would want to spend the kind of money that it would cost to fix it. But I had two machines given to me, so I'm doing it more for the challenge and to demonstrate how these boards can be repaired by recapping. Okay, that's got these, I guess there was 5 of them in here I replaced. 1, 2, 3, 4, 5, 6 of them. So I've got these remaining. I'm doing all the red ones. Those are the ones that are leaking. The other ones aren't spewing their guts out, I don't think. It's just the Elnas that were bad. These 2 here, well, I only have to unsolder 1 lead because the other one's burned off. So these ones will be a little easier to pull off the board. This is a 10 microfarad. I think this is also a 10. C11 and C20. These are both, yeah, these are both 10 mic, as you can see if we look at the close-up here of this part. Oops, a little too close. As you can see, the lead burned right off. Yeah, I got a bit of a problem with this tracer here. For the negative side. All these ones that are questionable, if the trace is damaged and so forth, I am going through with my meter and making sure that I have continuity to the next component over. So I am double checking that, even though I might not show it on camera, but I am double checking everything off camera to make sure that I have continuity where I'm supposed to. What's interesting to note is that all these capacitors that failed, they were all Elna Duro X2. They're 85 degree rated caps, so they've all been replaced with 105. Looks like some of the other ones here that I guess they're all 85 degree, but they're not all Duro X. It's only the Duro X ones, these red colored ones. I don't know what makes these ones so special, whether they were a special low ESR or something about them, but these ones here, they all leaked. Some of them to the point where the leads actually burned right off of them like this, right? But the others haven't appeared to have leaked. So I'm going to put the board back in and test it right now, just having replaced all of the leaking Elnas. So in total I've changed 12 of these crappy Elna Durex 2. Every one of them was leaking, and I've repaired some of the traces on the board that were also damaged. So reinserting the board, it just snaps in place. Like that. The tuner board swings into place, and I can. The nice thing about these units is they were really quite easy to get at to service them. Snap down the display board, reconnect the interconnect, and put the front panel on so that I have my buttons to control it. Front panel just lines up and it clicks into place. Ready for testing. So I got a tape loaded. What I'm gonna do is I've got it, hit record. Okay, I can record on this tape. I'm pretty sure this tape I can record on. Yep. Okay, hit record. And I'm gonna bring the levels up one at a time. So I'm gonna bring the left channel up. Hang on a second here. Why am I not getting a picture? Oh. I wasn't in record. Okay, left channel's up. And then I'm going to take the left channel down and the right channel. Left channel up. And I'll bring both. So it's recording stereo. And now we'll play this tape back and see what we get. Well, I can say on playback that I'm still not getting hi-fi sound, so we're gonna shut that off before we get a copyright strike. Back onto that board again, as obviously I'm going to have to change some more of the caps. I've changed the ones that were leaking, but I still have no hi-fi record or play. So we'll pull the board out again and check a few more of them and check and make sure that all those connections where there's corrosion, I'm going to start having to look. Not all the corrosion was around where the capacitors were changed. Some of it was on adjacent traces, so there may be some breakage there. So I'm going to have to go through there and just do some more measurements and see if I can find where the problem is. Okay, I'm just going to check this out. Take a look at the scope here, and you'll see that we're not getting good RF from both heads. It's like only one of the two heads is actually outputting a signal. These are the hi-fi audio. If I go over to the video, you'll find the test point for video. That's what there's our. That's not it. That's our video test point. Yeah, there's our video test point. I don't have my scope triggered, so you can see the two heads drifting through here. And if I put it into manual tracking and vary the tracking, you'll see that the levels will change. See, now my level's gone down. Now I'm bringing the level back up. That's our video head waveform, and this is the audio. And as you can see here, I only have one head. So either we're not switching heads to the second audio head, or we have a bad head. That would explain why there's no hi-fi audio playback. Now as I scope the other pins, I should have a switching pulse on one of these pins to switch the heads. And I don't see a switching pulse on any of these. The heads, the audio heads are switched separately from the video heads, so they have their own switch pulse, which should be coming off the audio board, I believe. I'm just going to see if I can find some service data on this thing. Switch pulses are generated from the audio board, and connection there doesn't look real good under a microscope, but I'm going to take a look in this area here because this is a connector. The switch pulses are processed, so this is the IC that's going to be doing the processing. And of course you can see some of these capacitors were in this area that were changed. So I'm going to be taking a look at some of these connections very closely to look for any damage. I don't know how well it's going to show up on camera, but if you look at pin number 1 on CN002, top right, it's cracked all the way around. So looking at these very closely, there are some connections on this board. I'm going to go over it with my magnifying glass and touch up anything that looks suspect, because I have seen a few of them on here, and that could certainly be part of the problem. And just pulling the board out and reinserting it has flexed these enough that they've broken their connection. So if I just happen to touch the board here, this connector, you'll hear the FM kick in with just one head.
In my case, the right hand's holding the camera.
Let's see, where's it touching here?
And of course, make sure that you're trimmed for the shot you want, because every time you let go of the left hand, you don't want the camera flying away to some other shot.
So what's happening there is I'm just creating just enough noise to cause the head switching to switch to both heads momentarily, or I'm unmuting it. We still got a problem on this board. I got to pull the board out again and go through it one more time and see if I can find a connection. But somewhere on this board we either got a broken connection or something that's blocking that head switching signal. Let's do a test one more time here. I'm trying something different right now, and what I've done is, you remember I replaced all the capacitors, and everything is looking good, but I'm only getting RF on, even on playback, I'm only getting RF from one head. And I'm looking for a switch pulse coming in here, but actually it comes in one of the other connectors over here. My switch pulse was there, but I'm only getting RF from one head. So I'm thinking maybe the preamp has a problem. So because I have an identical unit, I have a preamp. So I'm going to swap the preamp and see if it works. So I'm going to try making a recording and play it back. I'm going to hit record, and I'm going to start and just bring up one channel at a time. That way I can verify. So hit record, and I'll bring up the left channel. We'll record that for a few seconds, and then I'll turn it off, and I'll bring up the right channel, and then I'll bring both channels up. Okay, now if I'm recording in stereo and playing back stereo, obviously I'll see one channel, then the other, and then both come up. If it's only playing back mono, I'll see signal on both meters at the same time. So here's my recording. There's my left channel. And then it goes off. And then the right channel. This is not Super VHS, by the way. This is standard that I'm showing here. So, and now both channels are playing. We've solved the problem on this bloody thing. Now I'm just going to do a color bar recording and see how our color bars record now. Again, this is using a different preamp. This is the preamp from the other machine. The other machine that also has leaking capacitors on the audio board, and I'm sure that the caps on the preamp probably aren't far behind, but there's SP, and we'll switch it down to EP here. This is recording on a standard VHS tape. Once I verify this, I'll put in a Super VHS tape and we'll try recording on Super VHS. I'm actually kind of happy that that's all it was. I mean, obviously the capacitors that were all melted on the audio board had to be replaced, and I replaced all of those, and I still didn't have any hi-fi audio on playback. I don't know about record because I didn't test it. It wouldn't play back hi-fi. And it turns out to be the preamp. We'll open up that preamp and see what's inside it, but I bet you there are surface mounted electrolytics in that thing, and I bet you they're leaking, and I bet you that's the problem. Okay, let's see how our playback is now, and see how bad our color bleed is, which isn't actually too bad. It's not bad at all. Remember that we're looking at this on a plasma screen. If I look at it on an analog monitor, it'll probably look better because the plasmas tend to... there we go, there's EP. That's standard VHS. Not bad, not bad. Go back to, or that's EP there. Let's go back to SP. And there's the SP speed. And I think that color actually looks not too bad at all. Remember, color bars are the hardest thing to record, right? So it's looking pretty darn good. Let's try a Super VHS tape and see how it looks. Well, there's playback on Super VHS. Yeah, we're seeing a bit of from the rolling shutter, I think, on the camera. Yeah, Super VHS looks pretty good. You know, I mean, you got a bit of chroma noise in there, but that's pretty much normal for a lot of these machines, especially when you get something that's getting old like this. Red was always problematic. That was always where the noise was, mostly was in the red color sidebands. But yeah, the unit looks pretty darn good. Let's just try making a recording off of TV and see how it looks. So I'm just going to record a bit of a commercial here because I think we're probably okay with the commercial. I don't have to worry about getting hammered with copyright infringement. Crank my color up a bit on this monitor. Where's my tint?
Start for free today, 18+. Canada's vastness and extreme climate has shaped its people's down-to-earth character.
Oops, knock this stuff down here.
To yourself and to your community. The Royal Canadian Mint's
Just adjusting my chroma here a bit. I'm a little bit off.
Celebrates two icons of the Canadian
Can probably do it best with color bars. Calibrate my monitor.
Made from pure silver. No tax, free shipping, 30-day money-back guarantee.
And here's playback. Okay. There's my recording. Yeah, it looks good. Looks good on that monitor. If I swing down to the plasma here, as I say, when you're not recording color bars, it's not too bad.
You're not gonna let that happen again, right? Never again.
Start for free today, 18+. Canada's vastness and extreme climate has shaped its people's down-to-earth character.
And this unit, of course, has got frame by frame. Those lines you see drifting across the screen, that's actually the rolling shutter on the camera. Wonder if I can take my shutter speed down, whether that will. Not even at 1/60th of a second. It still does it, and that's because I went to automatic there. I'm at 1/25th of a second. Whoops. Shutter speed 1/60th. You still get a bit of that because of course video is not 60 frames, it's 59.97. So especially when you pause the image, it actually changes the frame rate ever so slightly because you're not looking at moving video, and now you're getting that line across the picture. It's not on the screen, it's just on the camera.
celebrates 2 icons of the Canadian
But there's playback.
Ford International
That's SP speed on Super VHS.
shipping.
Let's try doing a recording in the EP speed and see how it looks. Okay, I found another commercial that I can record now. And we'll see how this works. This is my live recording, and we'll show you the playback of this one momentarily. Sorry that I'm seeing the lines in the screen here off the camera. I'll try and defocus it ever so slightly to try and make it look a little better on the screen, but that's the problem when you're using a 4K camera and shooting a CRT. You're going to see all the individual little lines. And again, it looks much better on the monitor than it does on the camera. I apologize for that. The CRT does look better than the de-interlaced version of this going on the plasma screen, because plasma being a 480p, this is only a 480p screen, but it still has to de-interlace the interlaced picture, and they don't look as good. I mean, a CRT looks superior. In fact, what I'm probably going to do with this thing is I'm going to plug this into a larger CRT monitor just to evaluate how good it is, because as you know, with digital displays just don't do analog devices justice.
Will be able to eliminate the recent string of scandals resulting from LAPD misconduct.
And here's playback from EP. The EP speed actually still looks pretty darn good.
Just announced 0 for 72 on Ford F-Series.
Yeah.
Freedom from interest. Plus specially tagged pickups now get 1,000 smart bonus.
That picture looks just fine.
Trucks 39 years straight are built Ford top. Now get 0 for
Even the sharpness, look at that, I can bring the sharpness up on this thing by cranking up the sharpness. It's not bad.
Sweet cinnamon sugar on the outside, crazy on the inside. Crave those crazy squares.
Yeah, nothing wrong with that picture. Let's open up that let's open up that preamp module and see what's in it. Oh cool, I found a Montreal Jazz Festival tape. I'm gonna have to digitize this. I don't know who it is. I used to record all kinds of stuff, right? So I've got tons and tons and tons of stuff from on Super VHS. And oh, it's Herbie Hancock and the new Standards All Stars. Cool. This is, I mean, I've just been going through, I just grabbed some Super VHS tapes that I've got. I've got dozens and dozens of tapes, and I just grabbed one to see how it plays. This is a recording that an EP recorded years and years ago, and it looks great. Okay, let's crack this thing open and see if there are any surface mounted electrolyte capacitors in this thing. I'm pretty sure that we're probably going to find some in here. Okay, we'll just crack open the lid here. Okay, there's nothing on that side. Huh, it almost looks like that IC has been changed. Look at this. It almost looks to me like somebody's been soldering on this IC. See that? I think someone's worked on this thing. Okay, I gotta undo these solder connections over here to look on the other side, because the board's soldered in place. My iron is still warm, so let's just open this thing up and see what's on the other side of it. That's one side undone. Oh yes. Oh yes. What do we have here? I do believe that this one's leaking for starters. It's good to know, because the one I put in there from the other machine is probably going to go bad. It's probably going to leak too, so I better keep my eyes on that. We have some surface mounted capacitors on this thing. There's only a couple of them. There's one right here. Doesn't appear to be leaking at this time, but this one over here, this ELNA unit, is this one's bad over here. You can see it. You can see where it's puked onto the board. That's going to be the problem, and yeah, that's definitely going to be the problem with this. This thing plugs in like this too, so this connector here, this would be the audio. This is video over here. These are our test points for scoping for our waveform. And our video plugs in over here. This is the preamp for the video. This is going to be the RF preamp for the hi-fi audio. That capacitor's right in there. We only had one head coming off this thing. And it threw me for a bit because I didn't know where the pulse, whether the sync pulse or the switching pulse was coming in, because it is a delayed switch pulse. But it actually comes in on one of the other headers over here, and it was in fact there. But there you go. There's where the problem was, right there. So I bet you if I change that capacitor and this one over here in good measure, because well, we all know how great these surface mounted pieces of shit are, I bet you this preamp will work. But I don't need to worry about that now. And it really looks like this IC's been resoldered at some point too. But and even this connector down here looks like it's been did someone touch that up? See? Anyway, there's where the problem was. So say it didn't throw me that far after I replaced all the caps on the board, and I had no sound, no hi-fi sound. A little bit more troubleshooting led me to the preamp, and rather than take it apart and try and fix it, I figured, okay, I've got an identical one. Let's just swap it. And as soon as I plugged it in, away we went, off to the races. Problem solved. Hope you enjoyed this video, and we'll catch you in the next one. Now that I got this thing out of my hair, I can work on some of the other cool stuff that's backing up here in the shop. Some actual paid jobs for a change. Catch you in the next one. Bye. This slvr5 is got some more problems. The tuner has decided to not work properly. And this is probably going to be the same problem that happens on all the Sony TVs. The tuner craps out. It's going to be ground connection. So let's pop this tuner out. I didn't even get this thing back together. And the tuner decided it was going to crap out on me. So I just no sooner copied the files over to edit the audio problem. And now we can make a third part to this thing. So let's pop the front off it again. Kind of a good thing this thing packed it in before I got it all back together. I was going to leave that and do it tomorrow after work, and then this thing packed it in again. So let's just pop this open. Incidentally, I did change the capacitors on that preamp, and I actually popped the new one apart and changed the caps in that, and it fixed it. So let's flip open the preamp. Let's flip open the IF board. We're going to pull the IF and tuner out. That's on this board over here. This is the tuner here, and I guarantee you there's going to be solder connections broken in this thing. So let's just pop this out. I think it comes out like this. Not so sure how that opens, but it should pop apart. Once we've got the tuner board out, we're going to pull the tuner and the IF. This one's the MTS stereo. IF can is here, and we got to actually pull it off the board because I got to get into the base of this and into the bottom of the tuner itself to get a ground connection. So I'm just going to remove the solder off of these connections here and remove the IF module. is this one's quite easy to take off. Now this applies to everything that Sony made that had a tuner in it. TVs, VCRs, they all use the same tuner modules in them, and they all have this problem. When I was working in the service business back in the 1980s, I made an awful lot of money repairing bad grounds in Sony IF packs. If you look right down here, this is inside the tuner, right here. These pins that provide connection to the outside world, you can see that that one's cracked all the way around. I'm going to resolder all these pins in here and do the same inside this one here. I'm just going to look at it and see if I see any bad ones inside the IF pack, but usually it's inside the tuner. I'm going to resolder those, and that hopefully will be all that's wrong with this particular tuner on this one. It's usually what goes wrong. As I say, when I worked in the business, we fixed literally hundreds upon hundreds upon hundreds of Sony tuners on their TVs and their VCRs because they just all failed, and would get lines in the picture. Quite often some of these ground posts that went through here, through the board also were problematic. So just going to take a close look at them. Reattach the IF block. And of course the grounds. Now just to reconnect the board. Just put the plugs back together. Easier said than done. Oops. Get everything lined up, snap together. Front face back on the machine. And now we can test it out. So I'll power it up and turn it on. And where's my stupid video connector plug. The cable's broken. Okay, there we go. No problem now. Tuner's fixed. Don't want to show that but I can probably show that because I don't think they'll care about an infomercial. But there, my tuner's working. I'll let this thing run for a while, make sure it doesn't crap out again on me. But because it was working and then it went noise. So that's how to fix a Sony tuner problem. I made this video real short because this was a real easy one to do. I knew what the problem was going in. But say this slvr5 certainly has given me a run for my money. 3 separate problems with it. Power supply blown to smithereens, and then that audio hi-fi problem, which took forever to figure that one out. And then after getting that going, well, I shouldn't say it took forever to figure out, but it took a while. I had to change a lot of parts in it. And because there was multiple problems, we had the capacitors were shot, and also in addition to the capacitors being shot, we had a preamp problem. So there was 2 distinct problems, both causing hi-fi audio problems. And then after getting it all ready, almost ready to put back together, the tuner crapped out. So I'm gonna let this thing run overnight and make sure the tuner stays good before I throw it together tomorrow. But there's how to fix the tuners. That's what goes wrong with Sony tuners. Doesn't matter if it's in a VCR or whether it's in a TV, all those Sony tuners have problems. And as I said, when I was in the business, I fixed literally. There was days where I would do 6 or 7 Sony TVs a day at $100 a pop to replace, or not replace, but to repair the tuners. It was a huge problem that, as I say, still crops up from time to time. So there you go, slvr5 fixed. Hopefully I won't have to work on this thing ever again. This unit, I may just sell this one, put this one together and get some money out of it, because it's I mean, it's a nice machine when it works, but they aren't the most reliable ones in the world. Hopefully we won't be seeing this one again for a while. Anyway, hope you enjoyed this quick look at how to fix a tuner on a Sony tuner. And I'm not just saying for the slvr5, I'm saying any Sony tuner, whether it's in a CRT TV, I think, well, I wouldn't say so much their LCD TVs because I think they changed them there, but definitely all their VHS VCRs and all their Trinitron TVs use the same tuner block. And they all had those bad grounds and the pins where they solder onto the board. And you lose your AGC voltage and boom, you have mess like you saw on the screen. We'll catch you in the next video. Bye.